Hi, this is Lilly Aabye,
And this is Aubrey.
and we did our final project for CS 2316 on researching the harmful chemicals found in cosmetic products. We hypothesized that there is a correlation between cheaper products and the amount of harmful chemicals they contain.
Our project's purpose is to research which harmful chemicals are in which of our regularly used products. Our goal is to shed light on this problem and to grasp a better understanding as well as inform our audience. We cross-referenced our datasets containing information about popular cosmetic and beauty brands with the California Proposition 65 list. The California Proposition 65 list is a law that was put into place in 1986 that required businesses to provide warnings about exposure to chemicals within their products that could lead to harmful side effects such as birth defects, hormone imbalances, and cancer. We aim to identify the leading products with these harmful chemicals and to determine if there is a correlation between the price and the chemical content of the product. Our interest in this topic spiked when in recent years both of us were diagnosed with hormone imbalances, which have caused us a range of side effects such as fatigue, digestive issues, and sleep disturbances. While researching the cause of our imbalances, we found that hormone imbalances often come from chemicals and toxins found in the food we eat and products we use. Since then, we have been inspired to be mindful of the ingredients in the products we use. This is what inspired this project and why it means so much to us.
Started by searching for our CSV file. From there, we found our HTML file and then our API. The CSV file had to be at least 3 megabytes with 10 to 20 attributes. We had to web scrape one HTML file and then use one web-based file. Together, there needed to be at least 3 to 5 inconsistencies. Some of the struggles we faced trying to search for our CSV file for countless hours was the fact that there are very few APIs that access cosmetic products data. The API we did find had a very inconsistent formatting. The CSV file we found contained a table containing data such as product, the brand name, the chemicals used, the CAS registry number, and the names of reported chemical ingredients. We read the CSV file into a data frame, changed the chemical date removed column values to yes or no, filled the missing dates and the discontinued date column with a 0, and changed the NaN values of the CSF column to an empty string, and then changed all of the brand, product, and company names to lowercase for easier use with the API.
The HTML file contained a list of chemicals in the California Proposition 65 list. We imported the Beautiful Soup module and used it to parse through the HTML file. It parses data from the HTML to extract specific tables with the class wiki table. We found it and iterated through the rows from the first table, extracted the table data and table headers, adding them to a list, created a data frame with extracted data, wrote the data frame to a CSV file, and returned the data frame.
For our API, we used request.get to get a response object and then converted the response object to a Python dictionary. We then used JSON normalize to flatten the JSON into a data frame because the structure of the API was very inconsistent and hard to work with. We wrote the data frame to a CSV file and created a list of lists to parse through. We parsed through the list to see if ingredients was in the lowercase 10th column. If it was, we appended a tuple of the important data to a list. We created a new data frame with only the important data and changed the column names for easier use. We changed all the values in the name column to lowercase to match the CSV, rounded the values in the price column to a whole number, replaced all the strings in the category column with a space for easier readability, filled all the empty strings in the category and rating columns with NaN values to replace the missing values with the values in the product type category and float value to 0.0.
Continuing on to our insights.
For our first insight, we grouped the data frame by brand name and then applied the sum aggregate to the chemical count column. From there, we found that the top 11 brands that use harmful chemicals were Sephora, Charlotte Tilbury, NYX, Palladio, Bare Minerals, Sally Hansen, Revlon, Victoria's Secret Beauty, Tarte, NARS, and Number 7. For our second insight, we sorted the products into 3 categories based on product price. If the product was under $20, it was considered cheaper. If it was between $20 and $30, it was considered middle price, and then anything over $30 was considered a high price product. We found that 62% of products that contain chemicals are in the cheaper bracket, 24% are in the middle price bracket, and 14% are in the higher price bracket.
Through data collection from our HTML file, we found that 29.14% of companies discontinued the production of products with chemicals in them. Chemicals listed impose potential health risks for consumers that could lead to a variety of side effects. After the release of the California 65 Propositions list, which required businesses to warn consumers of the harmful chemicals contained in their products, we can see from our extracted data what percent of the companies chose to stop the production of harmful products. In insight number 4, we iterated through the data frame and extracted chemicals that are most commonly found in beauty cosmetic products. The goal of this was to help consumers be more aware and mindful of the potential toxins that are in their everyday products. We found the top 4 chemicals used from the California 65 Propositions list. In insight number 5, we found what makeup products are most likely to be paraben-free. Parabens are a group of synthetic compounds used as preservatives. They prevent the growth of bacteria, mold, and yeast, extending shelf life of the products. Parabens have been widely used for years due to their low cost, but studies have expressed concern about potential health risks. Parabens have been found to have estrogen-mimicking properties that could potentially disrupt hormone function in the body. Companies and consumers have expressed the importance of paraben-free and natural products. In insight number 5, we pulled data from our API to find what percentage of product types are most likely to be paraben-free. We found that the eyebrow product, foundation product, and the mascara product are the top 3 product types that are most likely to be paraben-free.
Our first visualization shows our second insight of the price breakdown per bracket in our pie chart. 62% of products that contain chemicals are under $20, 24% are priced in between $30 and $20, and 14% are priced over $30. For our second visualization, we use Matplotlib to graph a bar chart of the top 11 brands that use harmful chemicals in their products found in insight number 1.
For our visualization 3, we use Plotly to create a bar chart of the percentage of product types that are paraben-free from insight number 5. The visualizations help display the information in a way that helps the data collected come to life, and it shows it in an easier to understand format.
We created this GUI to help display and present our findings in a manner that is more interactive and easier to understand. We started by creating labels that say what's in your cosmetics, then created the next button that connects to the next button function when clicked. When you click the next button, all of the buttons are unhidden and the labels are hidden. The top 5 buttons you can choose to click that will connect to another function created for that desired action. You can choose to see the spread of price of products containing chemicals, top 11 brands that contain chemicals, percentage of makeup products that are paraben-free, the California 65 proposition list, and the list of brands. Clicking the spread of price products containing chemicals connects to the Visualization 1 function that uploads our first visualization as a JPEG from files as a Q label. It unhides the back button and hides everything else. Clicking the top 11 brands that contain chemicals button connects to the Visualization 2 function that uploads our second visualization as a JPEG from the files as a Q label, unhides the back button, and hides everything else. Clicking the percentage of makeup products that are paraben-free button connects to the Visualization 3 function that uploads our third visualization as a JPEG from files as a Q label, unhides the back button, and hides everything else. Clicking the California 65 proposition list button connects to the Cali function that reads the CSV file containing the chemicals in the list to a pandas data frame. Using the QList widget, we iterated through the substance column of the data frame and added each item in the list to the widget using an F string to display the number and the chemical. Clicking the brands button connects to the brand function that reads the CSV file containing all of our chemicals and brand information to the pandas data frame. Using a QList widget, we iterated through the brand name column of the data frame and added each item in the list as a widget using an F string to display the number and the brand name.
From the collection of our data, we have concluded that our hypothesis was correct and there is a correlation between products that cost less containing more chemicals. Through our extensive research and hard work, we are proud to present this project and to share with others what we have learned to help everyone live a healthier lifestyle. We've learned a lot while completing this project and have become more confident and skilled in our coding ability. We have become more mindful on the products that we choose and are thankful for this new information that we have learned and how it'll help us in balancing our hormones and on our personal health journey.
Thank you so much for listening to our project. We've put a lot of hard work into this, a lot of effort and time. We hope you've learned something. Lastly, this is a failed graph. It was supposed to be an animated bar graph, but it wouldn't stop looking like this. Bye.